Okay, so I welcome you guys all back to the new three tutorials. With our previous videos, we were dealing with matrices. We did that of 2 by 2 matrix using the matrix inversion rule or the Cramer's rule. We also treated the same matrices using 3 by 3 matrix. We also used the Cramer's rule and that of the inversion rule, and we solved application type questions under each rule, whether the 2 by 2 or that of the 3 by 3. So you can try and watch the previous videos to get the concept of matrices. So with today's video, we are going to start with differentiation. So the topic for today, we have differentiation. Now, when it comes to differentiation, what we are doing is we have rules that guides, or we have rules that we use when we are dealing with differentiation. The same applies to matrices. We also have rules, that is the inverse rule and what the Cramer's rule. When we move to differentiation too, we also have rules that guides differentiation. So now, the first, so let me do it this way. Rules guiding differentiation. So with the first one, we have power rule. With the second one, we have what we call the constant rule. Third one, we have what we call the product rule. The fourth one, we have what we call the quotient rule. We also have what we call the composite rule. But with the composite rule, it's most of the times embedded in the power rule. So when we are solving it, I would explain. When we are solving practical questions, I would explain. But for now, those are the major 4 we are going to deal with. So we have power rule, we have constant rule, we have product rule, we also have what? The quotient rule. So with the power rule, this is what we have. Y is equal to x exponent n. So if you have y is equal to x exponent n, based on differentiation, if you are using the power rule, it now becomes y is equal to x. Now, what is n? This is the exponent, this is the b. Now, what this exponent, it moves in front of the variable. So we have n here. Then that same exponent, you subtract minus 1. So we have y is equal to nx n minus 1. So this becomes the final answer when we are dealing with what? Power rule. So we are going to apply this concept we have here to questions pertaining to what? Power rule. So this is the power rule concept. So let me pick it one by one, then we'll solve questions under it. So this is the power rule concept. So I'm going to pick questions under power rule, then we solve it. So questions. So 1. So we have y is equal to x cubed. 2. We have y is equal to x exponent 4. Then 3. We have y is equal to x exponent negative 2. Now take note. Most of the times, students have conflicting issues when it comes to differentiation. Now we have this and we have this. we use this one for differentiation. And we use this one for derivative. Although we have the same answer, so we are going to get the same answers. But we use this for differentiation. Then we use this one for the derivative. So now, since we are finding for differentiation, the differentiation has to affect the rule. So we have dy over dx is equal to nx n minus 1. Like this. Because we are differentiating y with respect to x. So what we are saying is, out of this equation, we are finding for x. That is the whole concept. So in solving the question, so I'm solving question 1. Okay, so we have the power rule to be this. So this is the whole concept of the power rule, what we have here. So our first question, so I'm picking question 1. So this is solution. Y is equal to x cubed. So dy over dx. So per the rule, the number here, we move it in front. So we have 3x. Then the exponent, you subtract 1. So we have dy over dx is equal to 3x squared. So I'm done with the first one. With the second one, I have y is equal to x exponent 4. So dy over dx is equal to, the 4 comes in front, 4x. Subtract 1. So we have dy over dx is equal to 4x cubed. I move to the number 3. I have y is equal to x exponent negative 2. So I have dy over dx is equal to, this comes in front, the exponent, so negative 2x. The exponent, we subtract minus 1, so minus 1. So we have dy over dx is equal to minus 2x exponent negative 3. So this is all we have for the power rule. So we are moving to the next one, which is the constant rule. Okay. So 2, constant rule. So the constant rule states that y is equal to k. So dy over dx should be equal to 0. What we are saying is, the k here stands for a number or real numbers. Let me do it real numbers. So what we are saying is, with a constant rule, whenever you are solving a question, with a constant rule, it states that when you are differentiating any equation and there is a number standing alone, it automatically or it eventually becomes 0. That's why you could say it here. dy over the x is equal to 0. So whenever you are differentiating with respect to just a number, it becomes 0. So example, question. So these are questions under the constant rule. So 1, y is equal to 2x plus 1. I have 2. Y is equal to 3x squared minus 2. Then 3. Y is equal to 5x plus 3x squared plus 2. So I'm solving it. So solution. So question 1, I have y is equal to 2x plus 1. So dy over the x is equal to, now, whenever you are differentiating with respect to a variable, it automatically becomes 1. When you are differentiating with respect to just a number, 1, 2, 3, it eventually becomes 0. Just a variable, 1. Just a number, 0. Why am I saying it 1? There is the concept. Any variable, you know, it has an exponent of 1. We are subtracting 1, so we have this. So this gives us x exponent 0. X exponent 0 is equal to 1. That was how come we got this concept, where x is equal to 1. So when you are differentiating with just a variable, it's 1. Just a number, it's 0. So let's apply these concepts here. So why? dy over the x. This gives us 2. Remember, x has an exponent of 1 minus 1. Just a number becomes 0. So dy over the x, this is 2. X exponent 0 plus 0. So dy over the x is equal to 2. X exponent 0 is 1. So dy over the x is equal to 2. 2 times 1 is 2. Just a number, so 0. So now, we move on to the second question. So with the second question, we have y is equal to, this is a solution, y is equal to 3x squared minus 2. So we have dy over the x is equal to, you know, the exponent would multiply the number in front, or the exponent comes in front. So we have this. This is 3x. The exponent is minus 1. Just a number, you know, it becomes 0. So I have dy over the x is equal to 2 times 3 gives us 6x. 1 minus 2 gives us 1. But we don't have x1. It's the same thing as x exponent 1. So we leave it like this. So this becomes the answer. So we move to the third one. So with the third one, it states that y is equal to 5x plus 3x squared plus 2. So we find dy over the x. Just a variable, you know it's 1. Plus, this exponent comes in front, so we have 2. This is 3x, 2. We subtract 1. Just a number, you know it's 0. So dy over the x is equal to 515 plus 32 gives us 6x. 1 minus 2 gives us 1, but we don't bring the 1. So that becomes our answer. Dealing with what? The constant rule. So we are now done with the constant rule. So we move to the next one, which is the product rule. So the third one, product rule. So with the product, we state that y is equal to u v. Then dy over the x is equal to u times the v over the x. Plus, you know that per the concept of even board mass, when they are multiplying, we add. That's why you can see the positive sign here. They are multiplying here. So we add them. So u times the v over the x plus v over the u. V times the u over the x. So this is the rule we are going to use in solving any question pertaining to product rule. So let's pick our questions. So let me get some questions. So with question 1, I have y is equal to 2x plus x squared, bracket open, 3x plus x cubed. That's question 1. So with question 2, I'm looking for the second question. So the second question, y is equal to 2x cubed into bracket 5x exponent 2 plus 2x exponent negative 2 So let me put the calculator here. So you let me just clean the side so that, okay, you let me maintain it. So now, solution. So question 1, I have y is equal to 2x plus x squared, 3x plus x cubed. Please let's follow from this side. The rule states that y is equal to u v. Y is equal to u v. Now, you see we have two items here. And the equation demonstrates that y is equal to u v. So the first bracket picks the u. The second one picks the v. So we have u is equal to 2x plus x squared. I also have v is equal to 3x plus x cubed. Now, in solving this question, this is what the rule states, y is equal to u v. But for us to solve any question pertaining to product rule, this is the formula we use. So I have dy over dx is equal to u times dv over dx plus v is equal to du over dx. So now, with the u here, we already have the u. With the v, we already have the v. So what we are supposed to do next is, we need to find the v over dx. We differentiate v with respect to x. We need to also find the u over the x. Once we have all the information, what we do next is we will come and fix everything, or we will substitute our answers into the equation. Then we now start solving it. That is all. So I have dy. I have dy over dx. Okay, let me solve this one first. So I have dv over dx, meaning that we are going to find a derivative, we are going to differentiate v with respect to x. So we'll come and pick the v's equation. The v's equation. So this is the v's equation. We have 3x plus x cubed. So we differentiate this. So we have just a variable. So 1 minus 1 is 0. S exponent 0 is 1. So I have 3. X will give us 1 plus an exponent. You move it in front. So we have 3x. Subtract 1 from the exponent. We now have 3 plus 3x squared. So this is our answer for dv over dx. So now, we move to the u over the x. So we are differentiating u with respect to what? X. Differentiating v with respect to x. So I'm going to pick the u's equation, which is this. So I have 2x plus x squared. So in differentiating this, you know, just a variable gives us 1. So 2 to bracket 1. Plus this, 2 comes in front. So we have 2x, subtract 1 from the exponent. So du over the x is equal to 2 plus 2x. So this is what we have for du over the x. So we now have all the information now. So we can now substitute them back into this equation. So I have this. This is dy over the x is equal to u times dv over the x plus v over du over dx. So we have this. This is dy over the x. So u, this is u. So u is 2x plus x squared. Dv over the x, which is this. Dv over the x, we got this. So we fix this there. So we have 3 plus 3x squared plus, this is the plus v, this is our v. So u, this is the u, this is it. Dividing over the x, dividing over the x, this is it. So v, this is v. So v is 3x plus x cubed. Open bracket, du over the x, which is this. Du over the x, this is our answer. 2 plus 2x. So we simplify it. Now, if you don't take care, this is the side you might get problems with. So what I'm going to do here is, for simplicity's sake, so I'll pick this particular one first. So I'm naming this as my x. Then I'll pick this one second. So I'll name this one as my y. But when you become so conversant with it, there's no need of you doing what I'm about to do now. Are you okay? You just solve it straight away. That's when you feel you're okay with it. But for the basis to be corrected, that is why I'm separating it. So I'm naming this one x. I'm naming this one y. So I'll solve this first, then I'll solve this second. Then finally we merge it together because of the positive sign. So now, so with the x, so this is the x. So I'm solving the x equation. Okay, so as I was saying, so I'm naming this x, this y. So I'm going to solve the x first. So x, that's 1. We have the y over the x. We have 2x plus x squared. I have 3 plus 3x squared. So what we'll do is I'll pick the first one, which is 2x. Use the 2x to multiply. So let me name this one a. Let me name this one b. When you pick the first number at the a side, use it to multiply the whole of the b. So this is 3 plus 3x squared. Plus, when you pick the second number at the a side, which is x squared, you would also use it to multiply the whole of the b. So this is 3 plus 3x squared. So let's expand it. This time this would give us 6x. 2x times 3 would give us 3. Now, sorry, 3 times 2 would give us 6. Now this is x. Now when they are multiplying, we add their exponents. But when they are adding, we leave it like that. Once they are multiplying, we add their exponent. So 3 times 2 is 6. X has an exponent of 1. Remember that any variable standing alone has an exponent of what? 1. So we have x here. So 2 plus 1 gives us 3. Plus x squared times 3 gives us 3x squared. Plus, you know, we have 1 here, but we don't write the 1. So 3 times 1 gives us 3. So I bring my x. This is x squared. This is also x squared. So 2 plus 2 gives us 4. So with this side, what we are going to do is we first have to check if there are like, if there is any like terms involved. So we will check. This is 6x. This is 6x cubed, so you can't add it. This is 3x squared. This is 3x exponent 4, so you can't add it. So this one is our first one. So this is the x1. The x, what we solved here. So I'm picking the second one, which is the y. So with the y, we have the y over the x. So we have 3x plus x cubed. We have 2 plus 2x. So this is a. I'm naming this one a. This one b. So the a side, you pick the first number, which is 3x. Use it to multiply the whole of the b. So we have 2 plus 2x. The next sign here is plus. The next a side is x3. Use to multiply the whole of the b. So we have 2 plus 2x. So you expand it. This will give us 6x plus 3, 2, 6. X exponent 1, x exponent 1. 1 plus 1 is 2, so 6x squared. Plus this time this will give us 2x cubed. Plus 2, 1, 2. X cubed plus x squared will give us x exponent 4. So with this 2, there's nothing we can add. So this becomes our answer here as well. So this is y. So the final thing we are going to do is we merge it together. That is the plus. That is the plus sign you see here. So we merge it together. So let me clean the side. Okay. So I'm putting the, so I have the y over the x. With the one we name x, there's that. It's 6x plus 6x cubed plus 3x squared plus 3x exponent 4. You let me start at the downside so that everything would move from this side. This is 6x plus 6x cubed plus 3x squared plus 3x exponent 4. So there's the x. So I move to the y, which is this, plus 6x plus 6x squared plus 2x cubed plus 2x exponent 4. So there's what we have. So from this side, we check for like terms. So this is 6x. This is also 6x. So you can take it so that you don't forget to bring it again. So 6 plus 6 will give us 12x. Now, when they are adding, we don't add their exponent. It's only when they are multiplying before we add their exponents. So this plus this gives us 6x. We move to the next one. We will check if you have anything here. Yes, we have one here. So the same exponent, the same exponent. So 6 plus 2 would give us 8x exponent 3. So we are done with it. We move to the next one. 3x squared. We'll check if we have another one here. There's it. So 6 plus 3 will give us 9. So 9x squared. We move to this one. There's another one here. So 3 plus 2 gives us 5. 5x exponent 4. So this becomes our final answer. So the y over the x is equal to 12x plus 8x cubed plus 9x squared plus 5x exponent 4. So that's our final answer. So we'll move on to a different question. Now take note, one might ask, or one would stage that, but when you got to this point, you didn't do any differentiation. The differentiation was already done from the beginning. So with the rest, we are just expanding and grouping like terms. We don't differentiate anything on this side again. So move to the next question. Question 2, there is it. So question 2. Question 2, we have y is equal to, we have 2x cubed. We have 5x exponent 2 plus 2x exponent minus 2. So per the rule, we have y is equal to u vn. So u is equal to the first one, 2x cubed. Vn is equal to the second one. So this is 5x squared plus 2x exponent minus 2. So per the we have y is equal to u, the vn over the x, plus vn is equal to the u over the x. So we have u, we have vn, we are left with what? The vn over the x. So the vn over the x means we are differentiating vn. So this is vn, 5x squared plus 2x exponent negative 2. So we differentiate. So 2 comes in 4, which gives us 10x. 1 minus 2 gives us 1. So we don't bring it. So plus negative 2 comes in front. So we have negative 2. This is 2x minus 2. We subtract minus 1. So we have this. So this gives us, this is 10x. Negate 4 is negate 2 is what? 4x negative 3. So that's how we solve the first one. This is the 10x. We have 2 came in front, so 2 times 5 is 10. If you subtract 1 from 2, it will give us 1, so we don't bring it there. Negative 2 comes in front, gives us negate 4 is negate, so minus 4x. This is minus 2. We are subtracting minus 1, so it gives us minus 3. So this is what we have for the v over the x. Now we move to the u over the x. So we are differentiating u with respect to x. So this is u. We have 2x exponent 3. Differentiate. 3 comes in, for we have 6x. We subtract 1 from the exponent. So we have the u over the x gives us 6x squared. That's what we have. So we now substitute them into the formula. So we have y is equal to u, the v over the x, plus v is equal to the u over the x. So this is y. So the u, this is u. What is the u? This is u. 2x exponent 3. So 2x exponent 3. The v over the x. This is the v over the x. You have 10x minus 4x exponent negative 3 plus v. Where is v? There is v. So we have 5x exponent 2 plus 2x exponent minus 2. There is v. So we are left with the u over the x. The u over the x is what? 6x squared. So we have this. 6x squared. So we pick it one by one. So I'm solving. So the same format. I'm naming this one x. I'm naming this one y. You can solve it straight away. It depends on you. So this. So I have 2x cubed. I have 10x minus 4x exponent minus 3. So there's what we do. This times this. 10 times 2 gives us 20x. It already has an exponent of 1. So 1 plus 3 would give us x exponent 4. Minus 4 times 2. Sorry. 2 times negative 4 would give us negative 8. But watch. You know, when they are multiplying, we add their exponent. So what's this side variable? So this is x. 3. This is 3. This, assuming it was positive, it would have been 3 plus 3, giving us what? 6. Here lies the case. It's going to be 3 minus 3. So we have, this is 20x exponent 4 minus 8x exponent 0. So we can still simplify. This is 20x. This is 4 minus 8. X exponent 0 is 1. So I have 20x 4 minus 8. So this is the answer for the first one. So I move to this particular one, the y. I have, let me do this rule. I'm just bringing this one in front. 6x squared. This is 5x squared plus 2x exponent negative 2. So 6x squared would multiply this. So let me do this way. 6 times 5. 6 5 is 30. So 30x. When they are multiplying, add their exponent. So 2 plus 2 gives us 4. Now, 6 times 2. 2 times 6 gives us 12, so plus 12. This is x. The same issue here. When they are multiplying, we add their exponent. But this is going to be 2 minus 2. So this is 30x exponent 4 plus 12x. 2 minus 2 gives us 0. So we have 30x exponent 4 plus 12. X exponent 0 gives us 1. So we have 30x exponent 4 plus 12. So this is also our answer. So what we are going to do finally is we merge them together by adding. So I have dy over the x is equal to 20x exponent 4 minus 8 plus 30x exponent 4 plus 12. So we simplify it. So dy over the x. So this gives us 20x exponent 4 plus 30x exponent 4. We can add this one. This gives us 50x exponent 4. Now, minus 8 plus 12 should give you a positive number. So minus 8 plus 12 would give us 4. So plus 4. So this is our final answer. So that's how we solve the product rule. So we now move to the next one, what we call the quotient rule. Okay, so with the next one, we are touching on quotient rule, which is the last one. So 4. We have quotient rule. So with the quotient rule too, it states that y is equal to u over v squared. Then y is equal to v times du over dx minus per board mass. When we are dividing, we subtract, and that's why we are subtracting here. The previous one was what? Multiplying, that's why we added. This one is division, that's why we are subtracting. That's the explanation of the rules. So u times dv over dx divided by v squared. So this is okay. So I'm solving the first one. So I have y is equal to 2x plus 1 divided by 3x minus 2. The rule states that y is equal to u over v squared. So this one picks u per the formula here. This one picks v. So u is equal to 2x plus 1. V is equal to 3x minus 2. So the actual formula we are going to use to solve the question is, we have y is equal to v. This is du over dx minus u, the v over dx, all over v squared. So let's start. So we have vein. We have u. Now, the u over the x. So we are going to differentiate u respect to x. This u respect to x. So this is u. 2x plus 1. So in differentiating this, just a variable becomes 1. So we have 1 like this. This gives us 0. So our final answer is 2. So the u over the x is equal to 2. So you move to the next one. The vein over the x. So we are finding the we differentiate vein. So this is vein. So vein, I have 3x minus 2. So to differentiate this, just a variable, you know it's 1 minus what? 0. Just a number is 0. So our final answer is what? 3. So the vein over the x is equal to 3. So we can now use the formula. So y is equal to vein. This is the u over the x minus u, the vein over the x, all over vein squared. So this is y is equal to, with the vein, this is vein. Vein is 3x minus 2, the u over the x. Let me do it this way. This is y. Vein is this. So this is 3x minus 2. That's vein. We now need the u over the x. The u over the x is 2. So there's the u over the x. It's either you do it this way or you bring it in front. It's the same thing because you are multiplying. Minus u. So this is u. 2x plus 1. 2x plus 1 times the vein over what? The x. The vein over the x, we have 3. So the 3, there's the vein over the x. It's either here or you fix it here. It's the same thing, they are multiplying. Divided by vein squared. So this is vein. 3x minus 2 squared. So with this down part, with this particular side, you can decide to expand it or you would leave it like that. You can decide to leave it like this. Our concern is just the top side. The denominator, you can leave it like that or you can still expand it. Our focus is just the top side. So we have y is equal to 2 times 3 would give us 6x. Minus 2 times 2 give us minus 4. This is minus 3 times 2 give us 6x. Negative 3 times 1. Negative 4 is negative. Would give us negative 3. All over, we have 3x minus 2 squared. So one would ask, although you are seeing that with this side, you can decide to expand or leave it like this. How would we solve it if you are supposed to expand it? This is what we do. This is 3x minus 2 squared. It means 2 of this. So I have 3x minus 2. 3x minus 2. The first number would multiply the whole of this. So I have 3x. This is 3x minus 2. The next number is minus 2. This will multiply the whole of this. I have 3x minus 2. So 3 times 3 gives us 9. 1 gives us x squared. Minus 3 2 is negative 6x. Negative 2 times 3 gives us negative 6x. Nege 4. So 2 times 2 gives us 4. So we have 9x squared minus negative 6 plus 6 is 12. So negative 12x plus 4. So you can either use this or you write this one there. It's the same thing. It's still correct. 9x squared minus 12x plus 4. So it's either you expand it or you leave it like this. It's still correct. So let's continue with our question. So we have y is equal to, we have 6x minus 6x minus 4 minus 3 all over 3x minus 2 squared or 9x squared minus 12 plus 4. So y is equal to 6x minus 6x is 0. Minus 4 minus 3 is minus 7. All over 3x minus 2 squared. Or 9x squared minus 12 plus, let me check it. So it's 9, there's 12x plus 4. So we have y is equal to minus 7 all over 3x minus 2 squared, or 9x squared minus 12x plus 4. So that's the final answer. Either it becomes minus 7 over